Hey guys, welcome back. We are starting a new unit today, and this is going to be all about the atom and the periodic table. So we are just going to lay the foundation for talking about the structure of the atom today, and then we will, of course, move forward onto a little bit more complex lessons in the future. So today we are just going to be able to define the parts of the atom, talk about their descriptions, and be able to tell the difference between the three subatomic particles. So before we get started, let's just talk about the general breakdown of the atom and what it is. So this is the smallest unit of an element that retains the properties of that element. So atoms are microscopic. You cannot see them with a naked eye or even a microscope for that matter. So there are two areas of the atom. We have the nucleus and the electron cloud. And if you think back to biology and the nucleus of the cell, then the nucleus holds the DNA. It's kind of like the central part of the cell. Same thing for the atom. The nucleus is going to be the central part of the atom. But atoms are not living things. They're just the smallest unit of an element. So let's just make sure we make that distinction before moving on. So our nucleus, which is right here, so this would be the center of our atom, it's composed of two subatomic particles. Protons, which are positively charged, and neutrons, which are negatively charged. This also holds most of the atom's mass. So when we talk about mass, we know it's basically the weight of the atom. This is where most of it is contained, from these protons and these neutrons. Now, outside the atom here, or outside the nucleus, in the electron cloud, we have our electrons. So these little guys right here that we see in this picture, these are the electrons. These have a negative charge, and this is most of the atom's volume. And the reason for this is that these electrons exist in these energy levels outside the nucleus, so they're taking up most of the space. So the protons and the neutrons in the middle have the most of the mass, and then the electrons have most of the volume. So here is an image. I would highly suggest drawing, or at least trying to replicate a picture of this in your notes. So the red here in this particular picture is going to be our protons. Again, they have a positive charge, so think protons, positive. Protons, positive. And of course, they are located within the nucleus. So the protons are in the nucleus. When we write a proton with its notation, it's a P+. So the P for proton and the plus for the positive charge. And it has a mass of 1 AMU, and that stands for atomic mass unit. It's just a measure of a unit of measurement like gram, kilogram, etc. So it's an AMU. Neutrons are neutral. They have no charge here. This is that blue particle in the nucleus. So when we have the notation for a neutron, it's going to be N for neutron, and then the 0 indicates there's no charge because it's neutral. Neutron, neutral, no charge. This is also equivalent to 1 AMU. So protons and neutrons both have an equal amount of mass. And then finally, these little guys here outside in the electron cloud, those are our electrons, and they have a negative charge. So electrons are negatively charged. Their notation is an E for the electron, and the negative, which indicates they have a negative charge. And they essentially have no mass. So they do have a little bit of mass, but it's 1 over 1,840th times or the size of a proton, meaning it's just a small fraction of the mass of a proton or a neutron. And because of that, when we're taking into account the entire mass of the atom, we don't count the electrons. So we just say that they have 0. So when we're talking about the mass of the atom, we don't count the electrons in the mass. So now let's talk about our atomic number. Our atomic number tells us the number of protons in the element. So how many protons is present in the atom of the element. And these atomic numbers can be found in the periodic table. We've already talked about the periodic table. You guys know how to identify metals, nonmetals, metalloids. Well, the number that's in that element box tells us the atomic number, and it tells us how many protons are in the atom of that element. So the atomic number is equal to the protons. The protons also determine the identity of an element. So for example, let's take magnesium. Magnesium has an atomic number of 12. So it's always going to have 12 protons in its nucleus no matter what. If something happens and a proton is lost, then that would no longer be magnesium. So the number on the periodic table will always be the number of protons, and it tells us what element it is. It also tells us the number of electrons in a neutral atom, so meaning that the atom doesn't have any charge, and all we're worried about right now are neutral atoms. So in that same magnesium atom that we're talking about, if the atomic number is 12 and it has 12 positive protons, that means it will have 12 negative electrons in the electron cloud. And that makes sense because since the nucleus is positively charged, the electrons with their negative charge, if they're equal to each other, they'll balance each other out and the total charge of the atom will be neutral. So if you have 12 positive protons in the nucleus and 12 negative electrons in the electron cloud, the overall charge of the atom itself is neutral. And then finally, the mass number, so how much mass an atom has, can be determined by adding the sum of the protons and the neutrons. So remember, protons and neutrons both have a mass of 1 AMU. So if you want to figure out the entire mass of the atom, you have to just add those numbers together, okay? And remember, electrons don't have mass, so we do not count them. And here is just a graphic organizer to help us better organize this information. This information is already in your notes. You don't have to copy this chart down unless you are somebody that likes to have a graphic organizer and have all the information in one place. So the proton, P plus symbol, its charge is +1. Its mass is 1 AMU, or an atomic mass unit, and it's located inside the nucleus. So we've got those positive protons inside the nucleus. Our protons tell us the identity of the element, and in a neutral atom, it also tells us the number of electrons. Our neutrons, that symbol is N with the O, no charge because it's neutral, also 1 AMU, and also located inside the nucleus. And again, AMU is an atomic mass unit. And then finally, our third and final subatomic particle is that electron. Its symbol is E with the negative because it is negatively charged. So it's got a charge of -1, -1. And we say it has no mass, but it does have a relative mass of 1/1840. And it's outside the nucleus. It's located in the electron cloud outside the nucleus. Okay? And the last thing that we need to talk about today is how to read an elemental box on the periodic table. Again, you guys are familiar with the table. We talked about how it's organized. You guys know how to tell the difference between a metal, a nonmetal, a metalloid. But we need to make sure we know what each of these numbers in the box stands for, because you're going to have to do some work with identifying the elements, etc. Okay? So the smallest number on our box is going to be the atomic number. Okay, it will always be the smaller number. You're going to have two numbers in every elemental box. The smaller one is the atomic number. Okay, so in this one, we're doing carbon as the example. Its atomic number is 6. Remember, this is the number that tells us the number of protons, and it gives us the identity of the element. Okay, carbon is the only element with the atomic number of 6. So 6, like for example, carbon has 6 protons, and it would have 6 electrons in the neutral atom. Okay, so 6 protons and 6 electrons. The element symbol is just that abbreviated form of the element. The element name is self-explanatory. It just tells us what element it is. And then finally, the larger number is going to be our atomic mass. And remember, our atomic mass is equal to the number of protons and the number of neutrons. So for example, here, our atomic mass is 12. That means, because we already know that there are 6 protons, 12 minus 6 is equal to 6, so we know we have 6 neutrons as well. So we have 6 protons and 6 neutrons in that nucleus. We will do more work with that tomorrow when we talk about isotopes, but for now all we need to know is that the smaller number is the atomic number. It tells us the number of protons and helps us identify the element, and then the larger number is our atomic mass, which is equal to the number of protons plus the number of neutrons. Okay? And that's it for today. We need to know the 3 subatomic particles, so proton, neutron, electron. We need to know their charge, their location, and then we need to know how to be able to read all of the information in an elemental box from the periodic table. If you have any questions, as always, let me know. And if not, I will see you guys in our next lesson.